First question here is question number 13. So before we do these questions, let me just give you the formulas that you're going to use. So all of the questions in this set of questions, you're going to be using the sum and difference formulas. So the first, I'm going to write down what is the sum formula for sine. So the sum formula for sine goes like this. So sine A plus B, where A and B stand for two angles. So what this formula says is that the sine value of a sum of two angles is nothing but sine value of the first angle times cosine of the second plus cosine of the first times sine of the second. Now, if you're doing a difference formula, the difference formula will be pretty similar, except that you're going to have a minus here. Likewise, the cosine sum formula can be written as, cosine sum formula can be written as cosine A cosine B minus sine A sine B, and then cosine of A minus B is given as cosine A cosine B plus sine A sine B. And then you have the tangent formula, and the tangent formula is given as tan A plus B is tan A plus tan B over 1 minus tan A tan B. And then if it is negative, then it is going to just flip the sign. So we are only going to use these formulas in all of the problems that you're going to see in this standard. So let's start with question number 13. So in question number 13, we are supposed to find cosine 165 degrees. So let's do this. So cosine 165 degrees. Now 165 degrees is not one of the unit circle angles. So, but there is a value for it. Now, how do we find the value? We're going to see 165 degrees. Can this be written as a sum or difference of two special angles on the unit circle? Yes, definitely. There are several combinations that are possible. But one combination that comes to my mind is 120 plus 45. So 120 plus 45 is 165. So now there is a plus of two angles. So these two angles are added. And therefore, I'm going to use the sum formula for cosine, which says that. So this is the sum formula. Cosine of A plus B is cosine A cosine B minus sine A sine B. So this is my formula. Okay. So now all of these are unit circle angles. Therefore, I know the values. So I'm going to rewrite this in terms of A and B are going to be replaced with the 120 and the 45. So I have cosine A cosine B minus sine A sine B. So 120 degrees is in the second quadrant, cosine is negative, and 120 degrees would be negative 1/2. Cosine 45 is root 2 over 2. Sine 120 is going to be positive root 3 over 2, and sine 45 is root 2 over 2. Then since I'm multiplying fractions, I multiply across. Negative 1 times root 2 is negative root 2. 2 times 2 is 4. Root 3 times root 2 is root 6. Root 6 over 4. Now I combine this and write it in one single radical, like so. And that is my answer. Now question number 15 was to find tangent 15 degrees. Now I'm going to look at 15 degrees. It is not a unit circle angle, but it is a combination of two unit circle angles, such as 45 and 30. So this is one possibility. You could have even done 60 minus 45 or whatever it is that you want. So now that I have written that, I know that the formula that I will use will be the tangent difference formula, which is tan A minus tan B over 1 plus tan A tan B. Here A stands for 45 degrees and B stands for 30 degrees over 1 plus tan 45 tan 30. So tan 45 is 1, tan 30 is root 3 over 3, 1 plus 1 times root 3 over 3. So now 3 is a common denominator, so I can multiply and divide by 3. Because 1 times root 3 over 3 is just root 3 over 3 in my denominator. So 3 is the common denominator, and I'm going to multiply with that. And that gives me 3 minus root 3 over 3 plus root 3 as my final answer. Okay, let's see the next question. Question number 17 is sine 5 pi over 12. So you can convert this into a degree angle if you want, or you can just keep it as in radian measure and then see what you can do with this. Now 5 pi over 12 is not a unit circle angle. So now I can see how do I get it to a unit circle angle. Now 5 pi is nothing but 3 pi plus 2 pi. 3 plus 2 is 5. So basically what I have here is 3 pi over 12 and 2 pi over 12. Now what is 3 pi over 12? It is pi over 4. What is 2 pi over 12? It is pi over 6. So I can rewrite this as sine pi over 4 plus pi over 6. Then I apply the sum formula, sine A cosine B plus cosine A sine B. Then I just plug in. Sine pi over 4 is root 2 over 2 times root 3 over 2 plus root 2 over 2 times 1/2. Combine this, root 6 over 4 plus root 2 over 4. Put it under one radical and you are done. So that is question 17. Question 19 is cosine 7 pi over 12. Okay. So cosine 7 pi over 12, again, I look at 7 pi over 12 and I can rewrite it as 4 pi plus 3 pi, that is 7 pi. So then 4 over, this is pi over 3 plus pi over 4, and they are both unit circle angles. So I can rewrite this as cosine of pi over 3 plus pi over 4, and I apply the cosine sum formula, which is cosine A cosine B minus sine A sine B. Okay. Then I know all of these values, so I plug in. So cosine pi over 3 is 1/2 times root 2 over 2 minus root 3 over 2 times root 2 over 2. So I simplify this and I get root 2 over 4 minus root 6 over 4. And that is together root 2 minus root 6 all over 4. So the next problem is 21. sine 17 pi over 12. So 17 pi over 12. 17 pi over 12 can be rewritten as 17 is 12 plus 5. But 5 pi over 12 is not a unit circle angle, so I don't want to use that. I look at other combinations. What other combinations could I have? What about 15 plus 2? That might work. Or let's see. Yeah, I'm just going to go with 15 and 2. So I'm going to write 15 pi over 12 plus 2 pi over 12. Now 15 pi over 12, 3 is a common factor. So I get 5 pi over 4 plus pi over 6. So this can be written as sine 5 pi over 4 plus pi over 6. I apply the sine sum formula and I have sine A cosine B plus cosine A sine B. Sine 5 pi over 4. 5 pi over 4 is in the third quadrant. Sine is negative. Cosine pi over 6 is root 3 over 2. Third quadrant cosine is also negative. Okay. Then I multiply. I get negative root 6 over 4 minus root 2 over 4. Now I can combine this into one radical. And one fraction. And that is 21. The next problem I have is 23, secant negative. Okay, can skip that. So that takes us to the next set of problems, which is, so here when you have to do secant, you can just do the cosine and then just flip it. Okay, so the next set of problems that I have is 35 to 41 odd. So the first one I'm going to write down is 35. 35 is given that sine A is 3 over 5 and the angle is in the first quadrant. Cosine B is given to be 2 root 5 over 5 and this is the angle. So the question, what are we trying to find here? 35. Let me see. So in the next set of questions, we are finding all of these four, A through D. The first problem is 35, which we got started, but I'm going to do it again. So question number 35. What I'm given is sine alpha is 3 over 5, and I've given the alpha. Next one is cosine B is 2 root 5 over 5, negative pi over 2 to 0. Okay. So let's look at this. So what we have here is two angles. So the first angle is A. I'm going to call alpha A. It is in the first quadrant. How do I know that? Because it's between 0 and pi over 2. So my first angle is in the first quadrant, right? So this is my angle A. Remember that sine is always y over r, that is sine. So that means the opposite is 3, the hypotenuse is 5. And because this is the first quadrant, what I have is everything is positive, right? So both the x and the y is positive. Now, in order to find cosine alpha, I need to find x value. So for that, I set up my x squared plus y squared is r squared. So x squared plus 3 squared is 5 squared. Now this is a classic 3, 4, 5 right triangle, but I will just show you. Plus 9 is 25, x squared is 16, x is plus or minus 4. However, in the first quadrant, I know x is positive, so I just keep with x equals 4. Now, based on this, I know what my cosine alpha is. It is 4 over 5. Okay. So I've already been given sine alpha. Now I need cosine alpha. I find that. Then I also find tan alpha. Tan is y over x. So y over x is 3 over 4. And I keep all of this in one place for the first angle. Then I do the second angle. Now, where is the second angle? Let's see. The second angle is between negative pi over 2 and 0. So that puts it in the fourth quadrant, right? Because negative pi over 2 is here and 0 is here. So that is where it puts you. So now in this quadrant, you have this angle. So I'm going to draw the right triangle over it. And this angle is going to have so the x value is 2 root 5. It is positive, and the hypotenuse is 5. And I'm going to call this y. I already know that y has to be negative in the fourth quadrant. So I'm going to set up x squared plus y squared is r squared. So 2 root 5 the whole squared plus y squared is 5 squared. 2 root 5. So root 5 1 squared becomes 5. 2 1 squared becomes 4. 4 times 5 is 20. Plus y squared is 25. Subtract 20 from both sides. And then square root, you get this. But because this is in the fourth quadrant, I already know that y is negative root 5. Because I got the y now, I can write what sine is. Sine will be negative root 5 over 5. And tangent is nothing but y over x. So I have all of these values. Now that I have all of these values, I can find out everything that was asked of me. The first thing that was asked of me is what is sine A plus B? So that was the first part of the question. So to do sine A plus B, I use the formula. It is nothing but sine A cosine B plus cosine A sine B. Now, what is sine alpha? It was 3/4. What is cosine beta? It was given to me as 2 root 5 over 5 plus cosine alpha 4 over 5. Sine beta was, we found out to be negative root 5 over 5. So now I multiply. I get 3 times 2 is 6 root 5 minus 4 root 5 all over 25 as my answer. Okay. So the next one that I'm supposed to do for the same problem is what is cosine A plus B. So cosine A plus B, use the formula. It's cosine A cosine B minus sine A sine B. Cosine A is 4 over 5, right? Cosine B was 2 root 5 over 5 minus sine A is 3 over 5. Sine B is negative root 5 over 5. Four times 2 is 8 root 5 over 25. Negative and a negative makes a positive. 3 root 5 over 25. Now 8 plus 3 is 11. Root 5 over 25 is your final answer for this. Okay. So I'm just going to leave it at these two for this. And then you just follow the same thing. So for example, sine A minus B, this sign will just become positive. That's all, because the sign changes. And for tangent, you'll have to use the tangent formula. I'm just going to show one more problem in this, and then 2 more problems. So let's do 37. So question number 37 was tan A is negative 4 thirds. So this is what I have. So basically what I've been given is that the first angle is in the second quadrant and this angle is in the first quadrant. So I'm going to draw my alpha here in the second quadrant like so. And what I'm given is y over x is what I'm given. So, but it's the second quadrant, so I know that it is the x that is negative and the y is positive. So I know that this is a 3, 4, 5 right triangle, therefore this has to be 5. Now based on this, I can write what is cosine alpha. It's negative 3/5. Sine alpha is 4/5. Now I'm going to do the same thing for the second angle. The second one is in the first quadrant. It's like so. And in this quadrant, what I have is adjacent and hypotenuse. So now I know that based on that, the opposite has to be √3. Okay, and because it is in the first quadrant, everything is positive. So what I have is cosine B is 1/2 and sine B is √3/2 and tan B is √3/3. I'm sorry, √3. So now based on all of this, we can do whatever we want, but what I'm going to choose to do is the last two, sine A minus B and tan A minus B. So if I want to do sine A minus B here, what I will do is use the formula sine A cosine B minus cosine A sine B. I have all of the values. Sine A is 4/5, cosine B is 1/2, minus cosine A is negative 3/5 and sine B is √3/2. Then multiply 4/10 plus 3√3/10. So that gives me 4 plus 3√3 all over 10 as my answer. So now what I can also do for this problem is find out what is tangent A minus B. So to do that, I'm going to use the tangent formula, which is tan A minus tan B over 1 plus tan A tan B. So tan A is, how much was it? Was given to be negative 4/3, right? So negative 4/3 minus tan B that we found out was √3 over 1 plus negative 4/3 times √3. So now can you see that 3 is a common factor? So if I'm sorry, common denominator. So I multiply throughout by 3. So what happens is my first term becomes negative 4 minus 3√3 over 3 minus 4/3. And that will be my answer. Right. So now that takes us to the, so basically follow the same thing for all the problems. And now let's do question number 41. So question number 41 gives you that sine theta is 1/3. Theta is in quadrant 2. The first part of the question asks you to find cosine theta. So let's do that. So to find cosine theta here, this is quadrant 2, right? So quadrant 2, you know that cosine is going to be negative. So this is your triangle, this is your theta. Opposite is 1, hypotenuse is 3. So that means you have to find this. So this will be x squared plus 1 squared is 3 squared. So x squared plus 1 is 9. X squared is 8. X is plus or minus root 8, which you can rewrite if you want as 2 root 2, or you don't have to, doesn't matter. But we know that in the second quadrant, x is negative. So I'm going to keep it as negative. So that makes my cosine theta negative 2 root 2 over 3. So that is the answer to the first part of the problem. Now the second part of the problem was asking you to find sine of theta plus pi over 6. Okay, so to do that, sine of theta plus pi over 6, I will use the sine sum formula, sine A cosine B plus cosine A sine B. I already know sine theta to be 1/3. Cosine pi over 6 is root 3 over 2. Cosine theta is negative 2 root 2 over 3. Sine pi over 6 is 1/2. Then I simplify this. I get root 3 over 6 minus 2 root 2 over 6. Then I put it all into one fraction. The next part of the question is asking you to do cosine theta minus pi over 3. So use the cosine difference formula. Cosine A cosine B plus sine A sine B. So cosine theta, what is it? Negative 2 root 2 over 3, right? Cosine pi over 3, we all know that to be 1/2. Sine theta is given to be 1/3. Sine pi over 3 is root 3 over 2. So then simplify this. You will get negative 2 root 2 over 6 plus root 3 over 6. And that is what our answer is. The last part of this question is tangent theta plus pi over 4. So use the tangent sum formula, tan A plus tan B over 1 minus tan A tan B. So what was tan theta? We already found tan theta because we have cosine and sine. Cosine over sine is tangent. So that is 1 over negative 2 root 2. So let me write that down. So what is tangent? Tangent is sine over cosine, right? Which is 1/3 over negative 2 root 2 over 3, which is 1 over negative 2 root 2. You can multiply and divide by root 2 if you want, and that will be negative 2 root 2 over 4 is tangent. So I have negative root 2 over 4 plus 1 over 1 minus negative root 2 over 4 times 1. So this can be written as negative root 2 over 4 plus 1 over 1 plus root 2 over 4, because I just multiplied these two terms. So if you multiply these two, you will have negative root 2 over 4, and distribute with this, it becomes plus root 2 over 4. And as you can see, 4 is the common denominator. So if I multiply the numerator and denominator with 4, I will have negative root 2 plus 4 over 4 plus root 2 as my final